Hello everyone, I'm Alex, and welcome to our discussion on field axioms. This is going to be a two-part series. In this first video, we're going to explore the fundamental concept of field axioms, focusing primarily on the commutative and associative laws. In our follow-up video, we'll delve deeper into the identity, inverse, and distributive laws. As you may know, an axiom is a rule or statement assumed to be true in a given topic, such as number or geometry. It is a statement we can use to build our understanding of and apply to many topics in maths. For our purposes, field axioms are a set of rules we can assume to be true about addition and multiplication for the rational and real numbers. You probably already know most, if not all of these individually, but maybe not collectively. They can be generalized and also used algebraically to allow students to develop a deeper understanding of the rules that underpin arithmetic. There are 9 field axioms: the commutative, associative, identity, and inverse laws for both addition and multiplication, and the distributive law that connects the two. In part 1, we are going to delve into a more detailed exploration of the commutative and associative laws. Let's start with the first pair of field axioms, the commutative laws. The commutative law for addition tells us that we can add two values in either order. 6 plus 3 is equal to 3 plus 6. A plus B is equal to B plus A. We can demonstrate this by using lengths made up of the two numbers in both orders and show that they have the same total length. The commutative law for addition is helpful when teaching students to add negative numbers, as you can reorder the calculation to make it easier. For example, -2 plus 6 is the same as 6 plus -2. This tells us to start at 6, move 2 in the negative direction, which is the same as 6 minus 2. Similarly, the commutative law for multiplication tells us we can multiply two values in either order. 2 multiplied by 4 is equal to 4 multiplied by 2. A multiplied by B is the same as B multiplied by A. We can demonstrate this by using arrays or areas with side lengths of the two numbers in both directions, and show they have the same area. While addition and multiplication are commutative, subtraction and division are not. That is, 6 minus 3 is not equal to 3 minus 6, and 6 divided by 3 is not equal to 3 divided by 6. We will return to this in part 2. The commutative law for multiplication is able to be applied to percentages as well. A% of B equals B% of A. For example, 7% of 50 is equal to 50% of 7. Here, students can make decisions on what is the easiest calculation to do. In this case, 50% of a value is going to be the easier calculation. The second pair of field axioms that we are going to explore in this video are the associative laws. The associative laws are about grouping. The associative law for addition tells us it doesn't matter pairwise how we add three numbers. If you add B and C and then add A, you'll get the same result as adding A and B and then adding C. We can also demonstrate the associative law for addition by comparing the total length of lines and seeing that they are the same. While addition is associative, subtraction is not. That is, 6 minus 3 then minus 2 is not equal to 6 minus the difference of 3 and 2. We will come back to this later too. The associative law for addition is useful to take advantage of number bonds of multiples of 10 to make a calculation more efficient. For example, when calculating 13 plus 18 plus 12, it is easier to do 18 plus 12 first and then add 13 to get 43. Similarly with multiplication, the associative law for multiplication says that if you multiply A and B first and then C, you will get the same result as multiplying B and C first and then multiplying A. Blocks are a useful method here to represent that the order of multiplication does not change the answer. Here, we can see the visual representations and word them differently. Examples like this are useful when making links to shapes with different dimensions but have the same volume. While multiplication is associative, division is not. That is, 12 divided by 6 then divided by 2 is not the same as 12 divided by the quotient of 6 and 2. This is another point that we'll come back to later. The associative law for multiplication is useful to take advantage of products to multiples of powers of 10. For example, When calculating 9 multiplied by 2 multiplied by 5, it would be more efficient to first multiply 2 and the 5, and then the 9. Together, the commutative and associative laws allow us to rearrange any terms of addition problems and any factors of multiplication problems, including when we break down a number into a sum or product, because it works better with the rest of the problem, or to add like terms. Thank you for joining me in this video. Stay tuned for the next part, where we will dive deeper into the identity, inverse, and distributive laws within field axioms. See you there!